Good afternoon everyone. Today we are going to discuss differential amplifier and basics of the operational amplifiers. The differential amplifier configurations are completely different from the other amplifier types. It is a basic building block of an operational amplifier that we can call as op-amp. An ideal operational amplifier is expected to amplify the differential signal present between its two input terminals. As the operational amplifier is basically a differential amplifier, now let us discuss the differential amplifier and then analysis of the op-amps. Now here we will see first the introduction of the op-amps. I think in the first year of engineering you have learnt about the voltage amplifier using a transistor. It uses many other components such as coupling and bias capacitors, biasing resistors, etc. In order to get higher voltage gain, we will have to use more than one such amplifiers together. All this will make circuitry very bulky. So instead of using such discrete amplifiers, people started using amplifiers in integrated circuit form. The term operational amplifier or op-amps was first used by John in 1947. He used it to denote an amplifier which could be configured to perform a variety of operations such as amplification, addition, subtraction, differentiation, and integration. Hence the name operational amplifiers. During the initial days, the op-amps were being extensively used in the analog computers. Op-amp is basically a multi-stage amplifier which uses a number of amplifier stages which are interconnected to each other in a complicated manner. These internal amplifiers are transistors or FET as an amplifying devices. All this internal circuit with many transistors, FETs, resistors will occupy a space equivalent to pin head. The integrated op-amps has the advantages over the conventional amplifier as small size, high reliability, reduced cost, consumes less power. The first operational amplifier in an integrated circuit was brought in the market by Fairchild Company. They named this op-amp as 741, which became extremely popular and was used in a variety of applications. Op-amp is a linear or more accurately an analog integrated circuit. Now in the subsequent years, even though the number of op-amps, families and manufacturers increased to a great extent, the 741 remained one of the most popular devices. So if you see the symbol for the op-amp, it is mentioned here. There is a negative terminal, positive terminal. The negative terminal we can call as an inverting input terminal, and positive terminal we can call as the non-inverting input terminal. We have the output voltage and plus Vsat and minus Vsat level for the op-amp. It is a very high gain direct coupled multi-stage amplifier which is capable of carrying out mathematical operations like addition, subtraction, integration, differentiation, log and anti-log. Now we will move to the block diagram of a typical op-amp. If you can see, we have four different stages here for the block diagrams: input stage, intermediate stage, level shifting circuit, output stage. For input stage we have two inputs, inverting and non-inverting input. Then we have intermediate stage, level shifting stage and output stage, which gives the final output stage. Now let us see each block one by one. As we know, the op-amp is a multi-stage amplifier which can be represented in this block diagram. The op-amp is basically a differential amplifier, that is, it will amplify the voltage which is differently present between its input terminals. Now consider the first block of input stage. The input stage is dual input balanced output differential amplifier, that is DIBO differential amplifier, which is mentioned here, dual input balanced output. The two inputs are inverting and non-inverting input terminals. This stage provides most of the voltage gain of the op-amp and decides the value of the input resistance Ri. Then if you shift to the intermediate stage, this is usually another differential amplifier. The input stage devices, this drives this stage. The stage is a dual input unbalanced output, that is DIUO, that is dual input unbalanced output, that we can call as single-ended output differential amplifier. Then if we go for the level shifting circuit, due to the direct coupling used between the first two stages, the input of level shifting stage is an amplified signal with some non-zero DC level, and level shifting stage is used to bring this DC level to 0 volts with respect to ground. Then if you go for the final as output stage, this stage is normally complementary output stage for this last block, that is output stage. This stage is normally a complementary output stage. It increases the magnitude of the voltage and raises the current supplying capacity of the op-amp. It also ensures that the output resistance of op-amp is very low. The block diagram of op-amp shows that op-amp is basically a differential amplifier. Therefore, we will discuss the operation and analysis of the differential amplifiers from this onwards. So basically, before switching to the differential amplifier and equivalent circuit of the op-amps, we must know what is a CMRR. So CMRR is nothing but the common mode rejection ratio. The ability of a differential amplifier to reject a common mode signal, which is expressed by its common mode rejection ratio, that we can call as CMRR. It is the ratio of differential gain AD to the common mode gain AC. So CMRR is the AD by AC that we can call as the CMRR. So V0 output equal to AD into VD into bracket 1 plus VC by VD. So datasheet always specifies CMRR in decimal. If you want to switch this into the decimal form, then we can represent CMRR is equal to 20 log to the base 10 of CMRR. Now if you switch to the differential amplifier, then in that case we have to go for the different types of the differential amplifiers we have. The function of an ideal differential amplifier is that it is used to amplify the difference between two input signals. The difference amplifiers are used in many applications where the response from the DC to many megahertz is required. It is also the basic stage of an integrated operational amplifier with differential input. So if you go for the differential amplifier, it has two input terminals and one output terminal. The two input signals V1 and V2 are connected to the input terminals. Then the voltages V1 and V2 are measured with respect to ground. In an ideal differential amplifier, the output voltage VO is proportional to the difference between the two input signals. Hence the expression for the output voltage is given by VO is directly proportional to V1 minus V2. So differential signal VD is equal to V1 minus V2. So we can represent this as a differential amplifier. There are different types of the differential amplifiers. We can consider dual input balanced output differential amplifier, dual input unbalanced output differential amplifier, single input balanced output differential amplifier, and single input unbalanced output differential amplifier. So the differential amplifier will produce a zero output voltage if both the input voltages of terminal 1 and terminal 2 are equal. Means in other words, we can say that V1 is equal to V2. So we will get the difference between these two voltages equal to 0. A common signal to both the inputs, that is V1 and V2 is equal to V, will produce a zero output voltage. So this amplifier will amplify only difference of V1 minus V2 between the input signals. That is why the name is differential amplifier. Then if you consider the common mode signal, to both the input terminals, that is V1, V2 is equal to V, is called as common mode signal. The output voltage produced by an ideal differential amplifier is 0 for the common mode signal. Thank you.